hello everybody, thank you for joining us today for this exciting presentation in the School of Photovoltaics and Renewable Energy Engineering's lunchtime lecture series. Today we have Michelle Vaqueiro, who's a Senior Research Fellow here at SPREE. Michelle did her PhD at the University of Manchester and joined SPREE shortly after. She's been working in silicon defects for the last few years on ARENA-funded project activities, supervised by Professor Bram Hooks. And about 18 months ago, we started a conversation around industry and opportunity. And I was talking at the time with Muriel Watt, who will be known to many of you, about the opportunity for manufacturing for solar in Australia on the back of work that was done by Nathan Chang as part of his PhD on techno-economic analysis, and then Mohammed Degani Madva, who was working on local module supply chain. And anyway, so we then started a conversation with ARENA in late 2022 about the possibility of doing some analysis around supply chain to Australia, and we started work in February 2023, and Michelle joined the team to start to look at the solar supply chain for Australia to meet its long-term commitments to renewable energy and to power a green economy, particularly a hydrogen-based economy, the kind of solar we need to drive that economy, what that supply chain looked like and where Australia could play a role in that. February 2023 we started the work. October 2023 we submitted the report to ARENA, who shared it with government, and in March 2024 government committed $1 billion to the starting a solar supply chain in Australia. So I reckon that's a pretty good outcome for university research. It was we had an amazing team who were a part of that process. All of Australia's distinguished solar industrialists were a part of the supply chain. I'm not going to list them all, but you'll find them on the report. I'm really excited to hear Michelle give this long form summary of the work that was done. This is the first time that we've been able to share it at this level of detail. So welcome, Michelle, and I look forward to hearing your tale of the silicon solar supply chain.
Thank you so much. Thanks, Renata, for your kind introduction and for getting people excited about what I'm going to be talking about. First, I wanted to take a few seconds just to acknowledge what we're celebrating this year at UNSW. So this year we acknowledge that we've come a long way in the PV industry and history. There has been 20 years of graduates at the School of Photovoltaic and Renewable Energy Engineering, and then 50 years of research by Martin Green since he first started his research group. So this year is quite special. On top of that, there is the 75th anniversary of the university as a whole. So we're just celebrating massively and just taking a minute to acknowledge that and all those achievements. And also we're preparing an anniversary celebration / panel discussion on the 30th of November. Probably most of you would have already seen that invite on your calendars, but yeah, please mark the date because we would love to see you all there. So, as Renata said, I'm going to be talking about the silicon to solar study. And I just decided to go ahead and use a little bit of Australian lingo in my title here because I recently became Australian and I'm very, very happy. Thank you. And I think it was fitting for my talk today to frame it this way. So is this, a dream or an achievable reality? So can we actually make this work or not? And how far are we from getting that to happen? So Secondly, I need to acknowledge, just as Renata did, just very briefly, the people involved. Just the authors and the advisory board together amount for over 200 years of experience if we combine all these people and all the different perspectives and experience. So we definitely have a lot of input from the best minds in the industry, and in Australia, historically, industry, research, everything combined, plus a lot of all those, the key players in the industry as well outside the country who gave us input on what would be needed, how long would it take. We asked so many questions and we analyzed so many, data and perspectives to get to these conclusions that it's important that we acknowledge all that happened, and all was possible thanks to our sponsors and obviously the funding coming from ARENA that continues to support the PV activities in Australia. So first of all, why solar? Well, I think I don't need to convince this audience of why PV is important, but just for those who may be watching later or outside this room, solar PV is going to be one of the key drivers in the energy transition. That is a fact. It's been increasing so rapidly in the last 10 years that the deployment is just inevitable. So one of the forecasts or potential outcomes of looking at the future forecasts sees the potential of 70% of our energy coming from solar energy. So I think we should be looking at this industry just generally if we want to do an energy transition the right way. Then, so just as Renata said, so I did my PhD in Manchester, but then I came straight after in 2018 where that was happening. So this is here on your right, probably I can point here. So this is the annual PV installed capacity in Australia historically, and some projections that we've been looking at as well. And in 2018, we see that there was a massive uptake, and this was the result of basically lots of the increase in electricity prices, but also a massive drop in installation and solar PV costs. So it just almost it went over 2 times its annual capacity. We reached 10 gigawatts that year, which was a great thing to see. But today we're over 30 gigawatts of cumulative installed capacity, which is an amazing feat. But then if we just look now what's happened since then in terms of the supply chain, we see that it's just growing exponentially. This is an amazing result and unbelievable for a lot of people. But we've been doubling. So in the past, the industry was doubling every 3-4 years. Now it's almost going to every 2 years. The industry is doubling. So many things have happened since I joined UNSW, but I've seen so many great things and great minds and great ideas, spinning in my head now because of UNSW. So one big thing probably good to mention is that now Australia has had this vision since probably a couple of years ago that it wants to become a renewable energy superpower, and that means it's going to need even more solar. So even our small estimates of 5 gigawatts of annual production demand or demand per year would probably increase 2, 3, even 4 times if we do move towards fully green transition in the grid. What is the scope and methodology of this study? This was, even though Renata just mentioned it was a very short time, we did a lot of work. And that included looking at 4 stages of the supply chain, so going from polysilicon all the way to module production, and basically looking at techno-economic analysis. So how much would it cost? What's getting a sense of what's the minimum viable for us to play in the supply chain, then developing a business and policy assessment. So from the business perspective, what is needed, but also from the policy perspective, what would it be, what we need what would be needed to make this happen. So we did not include metallurgical silicon or quartz, just because there are some other studies looking at that, particularly quartz, for example, CSRO, and then metallurgical silicon. We already have some presence in that, and we already are playing a significant role in that part of the supply chain. So we were just focusing on the concentrated 4 steps going from poly to module, where probably not news for people in this room is currently heavily dominated by a single country. So the fact that it's dominated, it's been a long process even for that country. So China has been working and subsidizing our cheap solar PV energy for a long time, but now they've managed to basically develop at a very, very fast pace after development of the technology and just economies of scale and many things happening. So it did not happen over time. That's a very important point to make. So this didn't happen over time, and we're not expecting that Australia can also participate in a second in this supply chain. So risk or opportunity, one of the key drivers of this study was basically realizing that COVID happened, the war in Ukraine hit, and there were so many shocks to the supply chain as a result of that. So we have this amazing ambition of becoming a renewable energy superpower, but at the same time we have no control on what is going to happen with the modules that we need to make that dream occur. But also just in terms of for instance, our complexity index. So there are so many things that if we consider starting our own industry here would be benefiting our economy as a whole. Also, we will be moving to different exports. So if we are starting to export, for example, polysilicon. So just very, very slowly but steadily, we can grow our base of exports that are green-based export, because as you know, we are very heavily coal and gas exporters, but we need to move to different new frontiers from now on. One more thing regarding the risk, it should also be looking at, we should also be looking at it as an opportunity, because everyone is thinking about it. So even Chinese suppliers who are, in the game and they know what they're doing and they have the best technology in many cases, they understand the risk that concentrated supply chains have. So it's an opportunity for everyone to play in this opportunity, and I think, as you will see at the end of the talk, Chinese manufacturers are very aware of the situation and are very willing to collaborate. So unlike other studies of the similar vein of the silicon to solar study, one of our key recommendations for the government is for us to collaborate with the people that know the technology, that can deploy it at the speed that we need it and at the scale that we need it. So I'm going to go through. So there is a lot of content that you probably will see in the full report if you wanted to dig into it, but I just wanted to touch on the 4 different steps of the supply chain, main cost drivers, and some of the key insights from our study. So in terms of the first step, polysilicon production. So this is the scariest step from the whole supply chain from a cost perspective, because as you see here, so a lot of the cost of production, so it's coming from equipment and then electricity. So we can see this as a threat or an opportunity, because if we get to that point where we can lower the prices, ARENA is aiming to do, get low renewable energy electricity prices, then we can significantly drop the cost of polysilicon production. So it's a big commitment, just because the minimum viable, well, not just because, but one of the reasons is that the scale at which we would have to play to take part in this industry is of the scale of over 10 gigawatts of production. So that is a big commitment, especially because I just show you we have at the moment a demand of 5 gigawatts per annum. So thinking about producing 10 gigawatts, it's already kind of a big step. However, there is also that argument of whether or not we will be exporting these materials as well, because there is an opportunity and there is a hunger and there is a need out there as well for these products to be exported. And then, so if we look at the cost difference, also this has the highest barrier because we're talking almost double cost difference. So that could be seen as a big barrier, but at the same time, when talking, because this report, as Renata mentioned, it has already been published, but since then a lot of things have happened, and we keep being in contact with all those stakeholders that want to play in this, in the supply chain, and particularly coming from Chinese manufacturers, it's very evident that there are ways they can make this work with us. So they're willing, and they're willing to give us tools to make this work. And one of the key things that we just need to ensure in this particular segment is the electricity price. So if we can ensure low cost renewable energy, it's almost guaranteed that we can make it work. That is what's being mentioned by stakeholders at this point. And we'll come back to why Australia in a moment, but just generally that's the idea. So bottom line, polysilicon would be a great place to play. Probably not to start, because any polysilicon plant will require 3 to 5 years to even start working. So it wouldn't be the starting point, but definitely a key point for us to be playing at if we want to really secure that position in the supply chain. Then we have Czechoslovakia silicon, so ingoting and wafer production. This step is heavily concentrated at the moment in China, the highest concentrated one, and it's actually not a very difficult process, but it just requires electricity. So again, one of the big cost items would be coming from electricity. So if we can ensure that we have low electricity prices, then it's possible. Like literally, it's deemed as okay, plug and play. At this point in time, we have so many suppliers of turnkey lines that can come and teach you how to do these things and to start production at scale any moment. For that, we will need some support as well, just to get people in to begin with. But the equipment is there, the technology is there. Is the electricity costs that we would be needing to take a look at and resolve for these to happen. This is a very critical in terms of the technology. So different from polysilicon that has a lot of power, like in the supply chain, there's a lot of demand for it coming from outside of China. So there is an opportunity and huge opportunity there, and for exporting materials in general. But then in ingot and wafer, we're talking about the technologies. It's a different need and different opportunity and a different scale. So in terms of ingot and wafer, we've come to the conclusion that a capacity of 1 gigawatt production per annum would be the minimum viable for Australia to start producing. So anything less than that will not be benefiting from the economies of scale and probably make it a little bit more difficult for any new entrant to actually participate in the supply chain. But it's very important in terms of the technology, because it seems like no one else knows how to do these things, and the silicon is getting to such high purity that it's very important for today's technology that we maintain that level of quality. And if we already know, or some people already know how to do it, we should be definitely tapping into those technology people, basically. Then we have cell production. In the scope, we were focusing on TOPCon and PERC technology. The reason being that the next 5 years is going to be dominated by these technologies, and even looking after that, most likely we will be looking at silicon-based technologies. So we need to build an industry that uses silicon technology. Whatever comes after that, in the future, that is okay and should be doable for us to translate and innovate in that space. But at this point, it's about, okay, what's available today to meet the scale and the minimum viable scale and at the speed that we needed. And that would be looking at TOPCon and PERC. And also because, we're doing a techno-economic analysis and we need numbers, and this is what we can access to. So the numbers for production and cost, even though they're challenging to get, they're less challenging than any new technology that we would be assuming so many other factors in there. So in terms of the opportunity, it's a good opportunity for Australia if you think about the expertise, history, and knowledge that we already possess in the cell fabrication technology. So particularly here at UNSW, there is a long trajectory of developing new technology. PERC, TOPCon, were developed here in the 80s, but then translating that to an industry facility comes with its own challenges, and that would require, again, equipment. So materials and equipment would be the key drivers of cost. But it's very important in this particular side of things that we consider the depreciation time for tools these days. The way and the rate at which technology changes in the cell technology sector is just enormous. So we consider 7 years, I believe, in our study, but we're coming to realize probably every 3-4 years, people is changing their whole production line because new technology comes into play. So it's just much more changing in terms of how much you can stretch that production and for how long. So it would be good for Australia to play on it just because we have so much knowledge on the technology, but it would be a little bit more challenging to keep up with the speed at which things continue to change in the industry as a whole. Then we have the module production, which is the topic of a lot of people. So even if we look at other countries thinking about production today, they're focusing on module, and the reason being is the low-hanging fruit. So the cost gap is much smaller, the risk is much lower, but at the end of the day, it's probably not the best thing to be playing at just for a supply chain risk perspective. So we would need to be thinking about this as a starting point, not the end point. So the end point is to really play a role in the key parts of the supply chain, but not just the module production. Now, why Australia? So this is a big question. There are so many countries thinking about doing supply chain diversification. We have some comparatives here. So Australia, China, Southeast Asia, US, Europe, India, and Middle East. There are so many other countries looking at doing this because it's a major need and there is a huge demand for it. Even again, from the top manufacturers in China who are facing the risk of losing some markets that they cannot access because they are limited to their own frontiers. So they're really also looking into any product, any industry needs to develop a mitigation strategy for supply chain concentration. So it's very important from any perspective that we do it. And so these are just some countries that we considered. And we compared, okay, where can we play? Why would Australia, be a good place to do it? And here I'm highlighting kind of three different sections of the chart. So electricity and demand. From a business perspective, that's what the manufacturers and industry players want to see. So there is demand, there is people that is going to be buying my product, and then do I have cheap renewable energy prices. So there is a potential for Australia in those both very key factors from the business perspective. And then in terms of labor, materials, and IP, so these are other strengths that Australia can play with. Labor, in particular for polysilicon, you may have heard there are some concerns about labor conditions, and Australia is ranked at the top in the world on living and labor conditions. So the conditions here are very appealing for a lot of people wanting to work abroad. Materials, we have access to MG silicon, and there is a potential for domestic glass, solar glass. For those who may not know, when Sheng Ronxi graduated from UNSW, that ended up doing Suntech back in the day. So he started buying solar glass from Bondi or something. So when he started the industry once upon a time in China, he was buying solar glass from Australia. So it's just a little fun story about how things change and how things move around. And then in terms of IP, of course, the knowledge that is generated at the universities in Australia is well known. And then we have areas of opportunity. So in general, I'm just highlighting some bits where basically infrastructure, expertise, those things we need to work to get a better position on those parts. But in general, we have a lot of strengths to play with in the industry. So what do we need? So when we have analyzed the techno-economic analysis, we've analyzed the business side of things. So in terms of policy, what do we need in place for this to be a reality? And we've divided them in 3 key pillars. First of all, enabling policy. The enabling policy, we've subdivided in priorities, permits, partnerships, people, and concessional loan. So these enabling policies are step 1 in making anything happen. So priorities means we need to set our priority very clear. So we want to become a renewable energy superpower. We want to do green. We want to, clean our grid. We need a lot of solar, and therefore solar should be a priority for Australia. Then permits, if we look at permits, this is not an issue exclusive to Australia. In Europe, in the US today, they also suffer for a lot of hiccups and holds and waiting times for things to happen. So a streamlined process when it comes to deployment, when it comes to securing land, when it comes to getting everything up and ready for production, it's very critical. Then there is people. We need people that come with the knowledge. We need to train people that it's already here to make this happen. Maybe we can set up programs here. We can send them to other parts of the in the world to get trained and then come back. But we need people to do things. Partners. This is very, very important and quite, again, different from any other study looking at supply chain diversification today. So usual tactics would include increasing prices, tariffs here and there, but that would only risk our low-cost renewable energy, which is not what we want. So using partnerships with the right people, with the same vision, with the technology and the knowledge to make this happen, and concessional finance. So concessional finance has two main benefits. The first one would be securing, of course, that the players have some cash to work with, but second, to signal other players globally that Australia is invested in the technology, right? So even if you're just giving a little bit of support, just making sure that everyone knows that Australia is invested and has a solar PV as a priority, it's very important. Then we have the supply policy. The policy support in terms of supply would be basically all that support, concessional finance or production tax credits, or anything that will enable setting up facilities in terms of cost. And then the demand side would be, there is the risk, there is a perception of demand uncertainty, so we need to mitigate that by putting probably local content in incentives, or just incentives for PV deployment and installing capacity. And And yeah, so making sure that there is enough demand for these to be offtake, for the offtake at the end of the production. So what are the recommendations and key outcomes? I think doing well with time. So recommendations and key outcomes are highlighted here. And basically what we've done is basically a roadmap of how would it look like if we were planning to start operations in every single segment. How would that look like? In the short terms, as mentioned before, modules are the easiest and low-hanging fruit, right? So we need to start somewhere. That would be great. You know, this can be set up in 12 to 18 months if everything goes well. So that would be the first step. But then you already in parallel are thinking about the other segments. So solar cells, ingot wafers and poly would come as a priority as well, just because they take a little bit longer to make happen, just in terms of setting up production. And then lastly, we're putting here, and it's very, so it was on purpose that we did that, and solar cells come last in this planning, because again, the entry barrier for solar cell production could be a little bit more challenging, even though we own a lot of IP or we can generate a lot of IP. It's just a higher barrier there. So we suggest we should start with modules, but at the same time start thinking about the other segments and prioritizing ingot and wafer and poly, who are the key drivers for that risk mitigation perspective. And then we will, so we divided our recommendations in immediate actions, actions for the next year, and then 1 to 5 years as well of actions. And the immediate actions include basically setting the solar PV industry as a priority, an industry of priority for Australia. Determine the government, it's aligned with this plan that we're laying out, and then setting up a solar manufacturing task force, which is kind of what the Silicon to Solar team is doing at the moment. But we will see if that grows or that changes. But it's just the first step for making anything move. In the next 12 months, we will, be thinking about the support from permits, peoples and partners, and designing the frameworks, designing the policy, and then 1 to 5 years continue to develop and the technology and just consolidate the industry as a whole. So great news. We've progressed, as Renata just mentioned before. We've made such a huge impact in the program, in the beginning of the program of this Solar Sunshine. So $1 billion from the federal government have been now put in place and dedicated for supporting the solar PV manufacturing, and we continue to play a big role on what that's going to look like. But these will be covering basically a lot of the steps that we outlined in our report in October last year. So it's only May, and we've come this far. So the middle part is work in progress. So defining, fine-tuning, how are we going to do it, how much it's going to cost, where should we start, what's going to happen next. It's all in process, but we've come a long way very quickly, and we're very, very happy to see that. So just as a conclusion, and using a slide from one of our colleagues, so how are we going to do this? C3PO. So first of all, concessional finance. So giving the right signal and giving the right support for the industry to start. Three P's: people, permits, and partners. So we need people that it's trained. We need to enable people to be trained. We need people that it's already trained to come here with the right visas, with attractive opportunities for them to come and teach us here. Permits, approvals, partners. It's a very key thing to consider for making this happen right now. So we need to deploy, and I think the government is very much aware that we need to deploy PV, and it's doing its efforts to do that. But at the same time, we need to play a part in that supply chain, and partnering with the right people is going to be crucial. And then operational excellence, that would mean, highly automated plants, continuous improvement methodology, just continue to improve and innovate in the space after that. And thinking about end of life and circularity, so that all comes within the operational excellence. Well, so this would be the end of my talk. Thank you very much for coming, and happy to take any questions.
Thanks, Michelle. I hope you enjoyed that as much as I did. I'm going to add a couple more comments while you think about your questions. And one is that the work was led by the Australian PV Institute, Muriel Watt leading there, and Oliver Hartley, who did his PhD here, had a really leading role, particularly with the industry engagement and deep industry expertise in the program of work. And the important messaging around it is that the thinking was that any investment we made needs to be relevant, viable, and timely. And so relevant as in at a scale where you get the economies of scale. So we're talking gigawatts. Viable as in it's got to be an industry that is ultimately self-sustaining. We recognise to get it off the ground it needs help, and that's what the government is looking at supporting, but in the long term it has to be competitive. And timely as in the technology has to be ready now. It has to be working at scale now and be ultimately viable. So we're excited about where we are. It's been a very interesting conversation in the political and social and economic conversations around budgets and finance and treasury. And we're still navigating that. I'm happy to hear questions from you on any of those items and then the technology as well.
Yes.
Wow. Thank you, Torsten.
Well, thanks, Michelle, for a great presentation. In terms of relevant and timely, do you have any numbers in terms of what you expect, what capacity? You outlined, we're going to start with modules, and we're going to go to wafers and ingots, then poly, then cells, through to 2035, I think that was your chart. What sort of scale do you expect in terms of gigawatts of production so that it can be relevant? And in terms of timely, what are the timescales involved in reaching that in Australia?
Yep. Thanks, Torsten. So we've come to the conclusion that a minimum viable scale for ingot and wafer cell and module production, this is from many conversations, it's just looking at the available numbers that we had, would be 1 gigawatt production per facility, but aiming to build a 5 gigawatt scale by 10 years from now. So we were looking at a projection of 10 years. What can we do in that period of time? And it would be going from 1 gigawatt up to 5 gigawatts from ingot to wafer and to module. And for polysilicon, a minimum viable of 10 gigawatt production. So that would be 25 kilotons of production of poly. And the good news is that there are already some very strong and active participants in those areas. So Queenbrook has made a big announcement already in Queensland that they're willing to participate in the polysilicon side, and they have the right ingredients to make this work, and they're just looking for operational partners, which is basically what we suggested they should be doing. So, yeah.
And in terms of the 3 Ps, you mentioned partners is one of them. So do you expect that when it comes to module production now, that Chinese companies would actually bring their expertise to Australia to actually make that happen?
I think that would be, I think it's the consensus of the group, that would be ideal. And it's a possibility, just because, again, they are looking to diversify themselves, and they like the opportunity that Australia presents, and they're willing to come start work together the long run, or work for a certain period of time until things are ramped up, and then leave to locals to continue the work, because it's a reality as well that it's also not very easy these days to get these very highly skilled people from China, for example, to just leave their home country. So it would be also ideal for them, unless very attractive, for them to come, be here for 2-3 years. So approvals and permits, that's also what the time frame that we're thinking about. So a few years of visa for highly skilled workers, and then go back to their home country.
Yeah, I certainly believe that is the only way it can be done. But I guess you need to be mindful of managing the narrative there, because people already say, oh, Australian technology leaked to China, they make all the money. And now you have the government throwing in $1 billion. You make sure that people don't get the perception that now even we're throwing more money at Chinese companies making money in Australia. So that's possibly not what needs to happen, but I guess that's just a narrative you need to manage very carefully.
Yeah, definitely.
So you mentioned very quickly photovoltaic glass, but I wanted to sort of ask, has any sort of consideration been put into expanding supply in other areas such as encapsulants and backsheets and wiring and that kind of material?
Yeah, thanks for the question. So we did not look on this particular study. We did not look outside the 4 segments of the production, but it is part of the plan that we're working together with Arena to look at other avenues and other bits of the supply chain that probably Australia can take part of. So aluminium, solar glass, and other products will definitely come into play. It was just not included in this particular study, but it's likely to come in coming reports from work with Australia. So yes, we're considering it.
Thanks, Michelle. This talk was really excellent. I've got a question regarding sustainability. I believe you mentioned that energy is a really big requirement for the ingots, for example, the polysilicon. And I believe we have some very cheap energy here because we can produce it very cheaply. How viable is it to use solar electricity for such plants? And how much storage would you need to make it happen? Because sometimes the sun doesn't shine, or you might want to produce at night to make it economically feasible, and those kinds of things. Have they been studied to some extent?
So we only studied how much would it take for a 10 gigawatt plant to be producing, a polysilicon plant producing 10 gigawatts of polysilicon, how much would that take, or 1 gigawatt, 5 gigawatt production on the other segments. We did not dive into how exactly that was going to work, but we did mention in the report that there are some, so there needs to be storage included, definitely, because particularly for polysilicon, even though you can turn on and off the reactors, they need to run at a steady power, and also the cooling is very important in this plant. So I'm talking about specifically polysilicon, just because that takes the biggest chunk of electricity. So keeping the reactors cool and all those things will require a steady supply. But it is possible. So it is possible. That's what we're gathering from, again, conversations with Cranbrook, who's thinking about making this. But it would require, a lot of energy. We're talking about 1.4 terawatt hour consumption for a polysilicon plant, but it's possible to manage it.
So I'll just add that the big end of town are already looking at it now. So Rio Tinto are commissioning gigawatts of solar and wind. Fortescue are doing the same to run their iron ore processing capabilities. So the big end of town is already gearing up to do this, and the aluminium processing as well, and aluminium refining that we do in Australia. So it's not very different, silicon refining to aluminium refining. So we do have industry at that scale operating in Australia, and they're moving already to a green supply chain for their energy. Gavin.
I had a question on the costing. Very nice figures for the costs, and clearly modules are the closest to being competitive at present. And you mentioned a few mechanisms for reducing some of those cost components. But how critical is it to get those costs down to being comparable with Chinese prices, or are there some other criteria which would be just as important to bring in there, such as security of supply and other factors?
Yeah, so just because one of the criteria of our analysis was to not try to increase the cost of solar, we really want to match that cost of production, even though right now, these very moment, production costs are probably unsustainable and will not last for much longer. But these data is from last year, where things were looking still a little bit more steady. But it is a big, it is important that we maintain those low costs, just because we don't want to increase the electricity costs. Maybe we need to think about reducing the cost of transmission, because there is a lot of work being done in PV. We have very low prices already. Why are we not looking at other levers there, storage or other things that can actually drop the cost?
A very specific question. On the one of the first slides, you showed that the depreciation is like 3 times higher in Australia compared to China, especially for the poly. It made a huge difference. Can you explain why that is? Is that because it's such a high capex cost? And why? But I think the ratio was also much higher for poly than for all the other parts of the value chain. And what explains that?
Yeah, so because of the scale, so this is an assumption we had to make after discussions with stakeholders, because probably the cost itself would be twice as much, just bringing the materials and getting everything ready. But if you consider, basically, we just included it there, the time it takes to ramp up, it's much more at that scale. So for every single segment, it's going to take longer to ramp up than in China. That's what we know. But particularly for poly is where we see that it could take the longest time to really ramp up because of the scale it needs. So it was an assumption that we landed on because of different conversations, and also looking at other suppliers. So definitely Chinese suppliers give us the best price in terms of equipment and capex. But if you look at other suppliers, for example, German suppliers, that will increase the cost 5 times already. So kind of finding a middle ground where we're considering it, even going for the lowest supplier, so it costs lower cost supplier, but just how long it will take them to ramp up the process.
Okay, well, if there's no further, one more question over here, Rob. Like an auctioneer.
Torsten's question makes me think of another similar one, actually, on the materials supply. I noticed that the material supply was more expensive for all the Australian versions, all the technologies, as well as with other factors as well. Now that makes sense because presumably the materials feed in from from polysilicon to ingots to wafer to cells to modules. But for the polysilicon itself, I'm surprised. Why are materials more expensive? Because essentially they're is it the material supply that's more expensive, or the raw materials themselves?
So if you see the material is actually not much different. So it's the blue bit, and yeah, it's really not much different than the others. In the whole for parts of the supply chain, module manufacturing would take the highest percentage of materials, because the rest of the supply chain is coming from China, and the cost goes up from input materials.
Okay, as always, it's a case of trying to eat away at the largest factor, trying to bring that down, and then that feeds into the next stage, etc. But there's an ongoing process there for all that. But noting at the same time that the Chinese prices aren't going to stay still, so they're going to change as well. They're doing all the same things.
Michelle, Dorothy Dixon, I've got a question for you, and that is, how do you see Australia playing over the next 10 years in a global supply chain? Because it's not going to be, in 10 years' time, it's not going to be just China and Australia. It's going to be the US will have, they're investing at a scale in manufacturing. Europe has policies around it. And then Southeast Asia is playing in the game as well. India is a huge industry. So why does Australia need to do it at all? Why can't we just rely on diversification elsewhere?
Great question. So we have also thought about this during the process, and basically when looking at where would we play, where does it make sense, where do we have a chance, it's really thinking about collaboration. So at the end, I think I did put little notes here and there. Polysilicon, ingot and wafer would be the key, most important bits and segments to be playing at the supply chain. But then we've seen and heard an enormous appetite even from the US and from Europe to be buying from Australia. So that would be, so the US is definitely the biggest player at the moment, just pouring lots of support in their supply chain. But it is very clear that the builds that are happening potentially next year are they're all focusing on module and cell. So there is again a great opportunity for polysilicon and ingot to be to be produced here and to sell to all those markets. So I think it's going to be a collaboration. Even India and other players will be very, I think, willing to play with Australia to buy from our products. So I definitely see, and I would like to see those segments playing the biggest role in Australia.
Okay, last call for questions. Otherwise, I'm going to say thank you. One more, okay.
It seems like when you talked about it on a global scale, a lot of other countries are focused on module and cell production. So shouldn't we focus more on the back end of the silicon production, which was lower down on that list that you had earlier?
Yeah, I'm just reiterating from what I was just saying. I would like to see that. So we, in our roadmap, we basically started with module just because, again, it's something that we can start doing, and it just starts the industry, right? So it's a little push, and it wouldn't be too expensive, and it would create that kind of momentum. But at the same time, we're suggesting we should be looking at polysilicon and ingot and wafer primarily. Because those are being unattended at the moment and present the biggest opportunity. Even though the US is supporting these segments, the technology, so there are different things, but ingot and wafer, the technology is heavily concentrated in China, and if the US is not willing to collaborate and get that technology transfer, there is a block there, even if they're giving amazing support. And then in the polysilicon side, it's just, again, a massive infrastructure, and from that perspective, it seems it may not be enough, the support that the US is given at the moment, so there is an opportunity there for Australia to play a role.
Okay, so I'd like you, it's great to have such a fabulous turnout. Thank you all for coming today. I'd like you to join me in thanking Michelle for such a fabulous talk and the depth of knowledge that she brings.